hope more people join, but let's start. And the recording will also be available later today. Okay, so in today's session, we're going to start with one of the previous exam papers. What I'm also going to do is we probably finish this today and next week, and then we will, in that week of your exams, we will also have a few sessions, but if somebody can just also let me know what the final or what your exam date is. I think it's, I don't see it now around me, but I think it was all around the 28th, but not 100% sure. So if you can just put it in the chat again, that will be great. Okay, so let's start. And okay, so the first question, and okay, cool. So I was right about the 28th. So we will have sessions. Also strange, you guys are writing on a Saturday. So we will have sessions on the 14th and the 21st, and then in that week of the 28th, we will have also a few sessions. So we will have enough time to cover most of the work. Okay, so when we look at this previous exam paper, I think what's also important is they ask the questions, it's mixed up, so they don't start with study unit 1, then a few questions, then study unit 2, and work through like that. So sometimes that's also more difficult because if there is difficult questions in, one doesn't always know if you're on the right track. So most of the time, please just important to nearly keep track of what you're doing. Okay, so the first question, they tell us a line cuts the x-axis at 4. So if it cuts the x-axis at 4, it goes through y0 and cuts through the point where x is 2 and y is where x is 2, yes, and y is 4. So basically through that point and through a point up here. So I think the first thing that I would nearly look at is, okay, so that is 2, that is 4. So my y cutoff will be bigger than 4. So when I look through these options, that's not the option, that's not the option, that's not the option. So we're nearly only sitting with option 3. But let's go through all the processes. So firstly, we will work out the slope. So the slope m is equal to change in y over change in x. Okay, so remember, we've got y here and we've got the y there. So we can say y is 4 minus 0. And when y is 4 minus 0, we can say x is 2 minus 4. So that is 4 over minus 2. which is equal to minus 2. So we can see the slope is minus 2, so that is at least also correct to us for. So we basically sitting currently with y equal to 2 or minus 2x plus c. We need to calculate what c is. So I will substitute that point in, so the 2 and 4. So x is 2, y is equal to 4, or equal to minus 4 plus c. So if that goes over to the other side, we've got minus 4, that becomes positive 4. So 4 plus 4 is equal to 8. So c is equal to 8. And then we can just complete the formula of y is equal to minus 2x plus 8, which is then also the formula that we had. Okay, so that's nearly the first one where we look at equation. They give us points on that equation, and we will need to work out the equation. Okay, then the next one, they went into blocks. So a bit different in question 2, and that's why I'm also, the whole time we're going to go through, is you will see after this, we will go through nearly a total cost and a total revenue. So they're definitely mixing it up. So in this one, we will need to nearly answer the log question. First, you can nearly use your calculator for. So there's no reason why not. If you did not want to do the calculator and want to use the rules is basically log of a thing that's in the brackets. So 1073 divided by 7 divided by log with 3. Okay, so normally, and I think what is also important when we use our normal log function on a calculator, that normally always refers to log 10. So hopefully if you use a sharp calculator can calculate that. My HB does not allow me to use this or to put this into a calculator. So I will first need to work out this process. So if I take log of the 1073 divided by 7, I get 5,0323, and just see how clever that is from them. There is an option, but we still need to divide by the log of 3, which is 1,0986. Luckily, there's not one of them. And if I do that, my answer will be 4,581, which is option 2. Okay, so in this instance, you can also, I think the sharp allows you to put these kind of numbers in brackets into the log function. I know my HP does not. So if you have a sharp, you can do it without going to this route. But if you wanted to know how to do it without the calculator is the process that we will follow. Okay. So now we go nearly into something that we're talking about break even. So again, you can see they really mix up the questions. So it costs you R2.50 to print a paperback book, and it costs R1 to bind the book. Printing and binding setup costs of 1,000. So I'm nearly already putting down what my total cost will be. I don't know yet what I need to do, but I'm thinking let's put that down. So we've got the total cost, which is a fixed cost of 1,000 plus 2 variable costs. So to print, there's a variable cost, and to bind, there's a variable cost. And then they tell us these paperback books are sold to retailers for R4.75. So we've got a total revenue of R4.75 times Q. Find the number of paperback books that must be printed, bound, and sold to break even. So for break even, we know that total cost must be equal to total revenue. So before we do that, let's check out the answers. Okay, we can't have a negative. So you can't have a negative number of books. So that already is not the answer. If I look at why would they have minus 800, I would have nearly guessed 800, but let's work it out. So total cost function that we've written down is equal to total revenue. So we can take all the Q's to the one side. So the 1,000 will stay on the left-hand side. So if we take, then it's 4.75 Q minus 3.5 Q. So Q is, what is it, 1.25. And if we then say 1,000 divided by 1.25, we get Q as 800. Okay, which is option 3. I just want to check one other thing. If we luckily, if we added those two together, the 4.75 plus the 3.5, luckily there wasn't an answer for that. Okay. Okay, cool. So that was the way to answer this one. We need to nearly remember, okay, at break even, what happens at break even? At break even, total cost is equal to total revenue. So we need to basically then put the total cost function together, the total revenue, and then we solve for Q. Okay. So that is the first 3 questions, and then suddenly we go to a bit of a definition question. I think this was also in some of the the previous examples, I definitely know they like to put this in some of your assignments and things like that as well. Okay, so in this, the first thing I would add is to say, okay, they tell us it's supply and demand, but let's just put in that is the supply function, this is the demand function, just to, I don't want nearly to go through the questions and then by reading the questions, one gets upset and, or not upset, I'm confused, and then one starts guessing what you need to do. So let's look. Point A represents the break-even point. Okay. Line 1 represents supply. Line 2 represents demand. Okay, so we want to look at which one is true. That one is true. So what does point A represent if it's not the break-even point? Okay, it represents the equilibrium. Okay, so, and there's a slight difference between equilibrium and break-even point. So I think that's important. And suddenly you can see that if you said break-even, and remember break-even is when total cost is equal to total revenue. Equilibrium is when the demand function and the supply function is equal. So that where they cross. Okay, so just the difference between the two, because it's very easy to say, oh yes, that is where the two are equal, but actually the break-even point is when you look at total revenue and total cost. Okay, so let's look at so you could have stopped at that point. You don't need to nearly try and look at the others, but let's just look at what the rest actually means. Point B represent the minimum price consumers will pay. Supply, demand, so definitely not. The area of a triangle ABC represents consumer surplus, and again, not that whole part. Only half of that represents consumer surplus. So definitely not the total part. So that's why 4 is also wrong. So in this one, they nearly added a few things of your first few chapters into a definition question, because they ask you the break-even point, they ask you consumer surplus, which I think is in study unit 4, they ask you the demand and supply. So they've actually, for this question, they grouped a few of your study units together to get this question, but a question they love to ask. So, and in instances, they can even add numbers and ask things around the numbers as well. But question 4 is like one that they really love to ask in a paper. Okay, next question. We're looking here, they tell us we've got a demand and supply function. Then they ask us to calculate the equilibrium price and quantity. Okay, from the previous question, we know at that point is actually equilibrium and not break even. So that we can say that point is where the demand and supply is equal. So we know our demand function is 60 minus 0.6 Q, and our supply function is 20 plus 0.2 Q. If they have written one of those functions differently as a Q, then just rewrite it, please, so that you can say, no, but it is P is equal to, so that you can use it in this formula. So if I've given you the supply function as Q is equal to 0. I'm now guessing 0.8 plus 20, then please make sure that you nearly make P the subject of the equation, but I don't think that would have been it. It would have been something different. But just please make so that we can, at the next step, actually put the two equations next to one another. In this one, again, I like that all my positives is on one side, so I will take the 0.6 Q to your right hand side. So 0.6 plus 0.2 is 0.8 Q. Then on this side, 60 Q minus 20, so I get Q is 0.8 Q is 40. So if I then divide 40 by 0.8, I get my Q as 50. Okay, Q 50. So we nearly see there's no other Qs that are 50, so that is the right answer, but we can also just put Q back in one of those originals just to see if we get the same p-value. That is 60 minus 30, which is 30. So P is also 30. And important when you do it, because suddenly one can see it's also just swapped around. So just keep your head again when you do it, and not to see the first one, oh, Q50, and you pick P50 actually. So just again, be careful with that. Okay, so this was demand supply when it needed to be in equilibrium. Okay, and then we move into linear equations. So now suddenly linear equation, there is again a few linear equations. So I'll show you some of the others later on. But again, also how they structured the paper is not that all your linear equations are together. So we'll nearly at question 11 or 12, we'll get another one. And then a few questions later, we get another one. Okay, so linear equation. In here, they ask us, they give us an inequality, and they ask us this inequality um, which one of these below is the graphical representation of that. So the first thing I would do nearly is to say, okay, so let's look at, so we get y bigger or equal to 3x plus 3. So I'll just rewrite that nearly. And then it's like, okay, 3x plus 3. So we already know this is your y-intercept. So let's look at, okay, y-intercept, y-intercept, y-intercept. Okay, so this one I can already eliminate because we work with a y-intercept of 3. Okay, then if I look at the sign, the sign says it's positive. This is a negative slope. This is a negative slope. So the only one nearly that is a positive slope is this one. So let's just see if we just substitute some numbers, if we also get to this one. So automatically, I would have now just chosen 3, and we know that is bigger. So it's also fine. This side would have been smaller. So I nearly would have stopped here now and picked 3, but let's look at if I put in certain numbers. So I would first say, okay, let's put in where y is 0. Then I can see what that number is. So when y is 0, we've got 3x plus 3. So 3x on this side be minus 3. So x is equal to minus 1. So again, if I needed now to say, okay, so where y is 0, x is minus 1. So that now tells me that would have been the point. Here it's positive 1, positive 1. So again, why I eliminate these other two. Okay. So, and then obviously, because it's bigger, we need to, that goes up to say it's bigger. If we set to this side, we can see we're drawing the arrows down, which means it's going to be smaller than. Here we're drawing the arrows up because we're saying it is bigger than. Okay, so option 3 was the correct one, but very easy to nearly make the mistake to say, well, need to have bigger than. You had identified that 3, you might have misidentified for 1, and then one easily picks option 1 as your correct one. Okay, so just be careful and just jot down a few things to nearly identify on the line and clear that the x is minus 1. Okay, so let's look at the next question. Okay, so now we're going into the demand function of a certain product, and they want us to determine the consumer surplus of a product if a market price is 90. Okay, so they just give us they give us the line, then they tell us, okay, but at a certain price point, what is your consumer surplus? Okay, so let's just again rewrite this, so or plot it on on a line. So when Q is 0, we've got P as 120. When P is 0, we've got Q as, let's quickly check. I got Q as 40. I will just quickly work it out again. So when P is 0, 120 minus free Q. Okay, so free Q is equal to 120. Q is equal to 40. Okay. So this is our demand function line. Now they ask us, determine the consumer surplus of a product if a market price is 90. Okay, so market price 90. Okay, we need to work out what the Q is. So what we will do is say, okay, when it's 90, we will need to find out what is the value of Q. So we'll take that over. So minus 50 is equal to minus 3Q. So Q is equal to 10. Okay, so we know Q is equal to 10. So we will need to work out, let's say, the consumer surplus. So consumer surplus is this top triangle. So basically, we use the maths formula of half base times height, which is our half base is 10 minus 0, which is 10, and height 120 minus 90, which is 50. So a half times 10 times 50 is 300, and we get to 150. Okay, which is option 3. You can see what's interesting is, so when we worked out the Q as 10, there was also nearly an answer for that. Wonder how we would have got it to one of those numbers, but let's not now try to get to that. Okay, so consumer surplus questions ask a bit differently, so that you nearly need to see on the graph how you would get to it. They could normally have asked or added another. So instead of telling us P is 90, they could have given us that line that goes through there. So they could have done that as well. And then we needed to nearly put the two together and calculated what that point is. So that could have been the other way for them to do it as well. Here they told us the one is 90, so we could calculate it as 10, but else they could also just give us the formula of that line that is going through there. Okay, so again, a bit different question to what we have seen. Then interesting was that the next question, they actually ask us producer surplus. So what I've done is, and this is not for answer, I just copied one of the the examples of out of the study guide. So at one just see what you need to do actually. So they ask us to work out the producer's surplus by looking at a quadratic equation or a supply function. Then what they also tell us is that at Q equal to 10, we will need to work out what the supply of a producer's surplus is. Okay, so now the first thing we will need to do is, what do we do to nearly work out the producer's surplus? We will need to work out that whole area. So let me just add some numbers in here that you guys can identify with. So that number should be 10, because that is what they give us. To get to that number, we will put in 10 into this equation. So let's do that first. To solve what P is there, let's put in the equation. So that is 10 to the power of 2 minus 2 times 10 plus 12. So that is 100 minus 20 plus 12, which gives me 92. Okay, so that is 92. Let's take all of these things away. So when we working out the producer surplus, what we're going to do is to say, okay, we're going to work out that the triangle, which is that whole area. Then we must take away the piece underneath. So, and that part we actually get by using the integral of. So what will be the easiest to nearly say? We're going to work out the integral of that function to get to the area underneath, and we're going to subtract those two. So it is going to take a bit of work. So let's now work with the integral that we need to work out. So q to the power of 3, q to the power of 2 will become q to the power of 3. But remember, again, divide by 3, so it get 2 plus 1. Then we say that's 1, so 1 plus 1, it becomes q to the power of 2 divided by 2 plus 12 to the power, or to q. We're not going to add c, because when we going to put in 10 and 0, c will automatically fall away. So we're not going to do that. So basically we will now need to work here with 10 and 0. So there's 10, there's 0. So with that, we will now put in 10 into Q, get the area, then subtract the the zero. So let's just quickly see how we're gonna work that out. 10 to the power of 3 is 1,000. So 1,000 divided by 3, that and that cancels out. So we have minus 10 to the power of 2, which is minus 100, plus 12 times 10, which is 120. And you can see if we now needed to subtract the 0, that times that is 0, that times that is 0, that times that is 0. So to put in the 0 would actually have just given us a 0. So 1,000 divided by 3 is 33.33, minus 100 plus 120 will give us this that 353, which, look, there is an option, but that is only now this component. So it's not the answer yet. We need to say 92 times 10, 92 times 10, which is that square minus the integral that we have now worked out. So 920 minus 353.33. And that answer, 920 minus 353.33, is 566.67, which is option 2. Okay, not a short process, not an easy process. Lots of things that you needed to do. You needed to work out firstly what the bigger area is going to be. Then you needed to work out then you work out the integral, and subtract the 2. So what I always do, and what I will send you guys, I will actually send it today on the group, is also just a summary of the formulas, and I've written a few of these things in so that you nearly can see, and that's also for me why I always add these things, because now I can see where my producer surplus is, that I nearly know what to get to, so that I don't, because you can see all these answers is very close to one another, or are being used somewhere inverse, so nearly that you don't know or don't make a mistake by choosing the incorrect one just because you didn't highlight maybe what you need to do. Okay, so I will share that afterwards on the group as well. Okay, so next question is, now suddenly we go back to equilibrium, and in here again, they tell us find the equilibrium price and quantity for demand and supply. None of it nearly are duplicated. So if we know the price, we can then stop nearly. We don't need to go on to the quantity, but I will quickly show how we do both so that you can just see that if there is duplication. So they tell us, okay, those two, we work in equilibrium. So 24 minus 3p is equal to 4 plus 2p. So let's take all the p's to that side, minus 3p to that side. So we've got a 5p on this side, on the right-hand side. This becomes negative. Let's take it to this side. It's 20. So p is equal to 4. Okay, so p is equal to 4. So we know option 1 is the correct one. But let's just say this was not 3 but 4. So we need to work out q. So what I would do is, I don't like negative, so I will rather work with positive. So I would say okay, let's replace my p back into this formula. So 4 plus 8 will give me then q of 12. Okay, which was that. Okay, so this was actually, if I look at it, not too bad. Just look at, there's so many options that have a free and before, and so once again, just be careful when you look at these, that you don't make a mistake by picking the wrong one. Okay, so that was again price and quantity from demand and supply functions, and you needed to go back to what the equilibrium is. Okay, the next one is a bit more difficult. So now we're using total revenue, total cost, but with a nearly linear equation methodology. So they want us to work out what's a total revenue, total cost, and total profit functions. Okay, so when I look at this, I would then say, okay, let's write down. So the company produces Q solar lamps at a fixed cost of 5,000 per week. So we can say total cost is going to be, they're going to tell us now how many, but Q plus 5,000. And the variable cost of 150, and the variable cost is 150. Okay, so there's the variable cost, there's the fixed cost. Okay, so I can now already go to total cost where it's all in these functions. I can say, okay, total cost 150Q plus 500. Okay, so this one seems correct. Total cost 150Q minus 500. Okay, no. Total cost 150Q minus 500. Okay, no. Total cost 100Q, also no. So actually, by just formulating that first one, in this instance, we had the right answer. But let's look at first, what is your total revenue? Okay, each lamp is sold for 300 rand. So total revenue is 300Q. Okay, so total cost was very correct. Total revenue, yeah, the total revenue was fine, but total cost wasn't. They're also wrong. They're also wrong. So they nearly swapped around some of the total cost and total revenue. We already know which one is right, but let's just make sure that we get the profit function. So profit function is total revenue minus total cost. So we've got 300Q minus 150Q minus 5,000, which then is 150Q minus 5,000. Okay, total profit 150Q minus 500. That one is also correct, and you can see all of the others in any case also wrong. So option 1 was the equation that we went with. Again, at our first principles, nearly how you can calculate it from just writing down what your total revenue will be, what your total cost will be. So if you've written down total revenue first, you would have gotten out of total revenue those two. Then if you've done total cost, you would have only been left with that one because you would have cancelled out this one. So, again, just start with one and see how many you can actually eliminate. Okay, so let's quickly then go to the next one. So they said questions 10 and 11 are linked. So we nearly need to remember that total revenue, total cost, and profit function. So let's just gonna copy it. Crop it, because we now knew that top one was the one we're going to work with. Okay, so they tell us in question 11 how many lamps were produced and sold if they made a loss of 2,000. Okay, so we can go to this profit function. We don't need to worry now anymore about the total revenue and total cost. We can go to a profit function and say, well, what profit am I making? Well, I'm actually making a loss. So my profit function is just negative 2,000. So 150Q on this side. I'm going to take the 5,000 over to that side. So then it becomes 3,000. So Q will then be 20. Okay, which is option 1. Look at if you have done 20Q or 150Q minus 5,000, and instead of saying negative 2,000, you just said 2,000. Then you go through the whole process the same. 150 will be equal to 7,000. So then if you say 7,000 divided by 150, you get an answer of 47. Okay, which is actually there. But remember, we're not making a profit, we are making a loss. So we need to remember in your profit function that your profit is negative that you're making. So we will need to say minus 2,000. But just, if you did not, unfortunately, there would have been an option for you as well, which would have been the wrong option. So when you do this, just be careful. Again, if I have in the exam a few different question sets for the students, this might be one where to one group they say made a loss, and to another group they say break even, and to another group they say made a profit of. Okay, so again, just be careful what they're actually asking you in the question. If it, let's just quickly check. If it was break even, that would have been equal to 0. So 150 Q would have been equal to 5,000. 5,000 divided by 150 would have given you 33. Okay, so even if you made the mistake of just going break even, there was an option as well. Okay, so just be very careful when we do these kind of questions. Okay, then we go into the next question, which again is a linear programming question. Now it nearly gives us the 4 equations or areas that we need to work with, and we need to nearly say which one we eliminate. Okay, so the first one, we'll do it step by step. So the first one that we look at is the easiest one. So they tell us that the x and the y must always be positive. Okay, so x and y must always be positive. So we're only working in this quadrant. Here x is negative, here y and x is negative, here y is negative. So we can't work with this one. So just by looking at this equation, I have eliminated one option. Okay, so it needs to be bigger than 0. It needs to be bigger than 0. So it can only be that one, or that one. Okay, option 1 gone. Okay, so then let's look at the other options. So I would take that first one. So I would say, okay, let's look at y smaller or equal to 13 minus x. Okay, so we know there's a negative in front of it. So that is when normally one of these negative axes or lines, but let's work it out. So when y is 0, we have 13 minus x, which makes it that x is equal to 13. So when y is 0, x is 13, there it is. The same now when x is 0, y is equal to 13. So when x is 0, that means y is equal to 13. So we've got that one, that one, that one. So that is all fine. But let's see, it's all smaller than or equal to. So it must be smaller than or equal to. Okay, so that tells me that that area then is out of bounds because it needs to be smaller than that. So option 2 is also off the table. Okay, so by just looking so far at question or linear equation 4 and 1, we have eliminated two options. Okay, so let's look at the next one. I'm first going to skip the negative y, so that we just work with things that are positive y's, just to make that component a bit easier. So 3y smaller or equal to 2x plus 12. So let's divide by, can't divide by 3, can't divide by 2. Okay, so let's do divide by 3, so that we get y as its own. And this one then is a bit different, 2 over 3, but at least we get the y cut off as 4. So let's look. Y cut off 4, yes. Y cut off 4, yes. Must be smaller or equal to, smaller or equal to, so that is still fine. Smaller or equal to, so this one can also still happen. Okay, so then the last one is then 2x minus y smaller or equal to 8. Okay, so let's just get all the x's on the right hand side. So 2x plus 8. Okay, so when I want to make that positive, the important thing is when that becomes positive, the sign will change. So y becomes positive, but then this sign will swap around. Okay, so we can multiply by -1 throughout, but then remember the sign will change. So in this one now we say that y is bigger than, you can say bigger than, so this one would not have been, so we sit with option 3 as your correct. If we did not swap that around, we would have said smaller than, and then we would have ended up with option 4. So very important, this rule of when we multiply by -1, remember that the smaller or equal to becomes bigger or smaller than. Okay, because that will make us in choosing the wrong one if we don't stick with that. Okay, so linear equation where you need to, they give you 3 or 4 linear equations, and you will need to then look at the different graphs to say which one is going to be the one that is the designated area nearly. Okay. Okay, so let's go to the next one. Now in the next one, we're looking at a demand function. So if a demand function is equal to P is equal to 70 minus 3Q, with P and Q the price and quantity respectively, determine price elasticity of demand if a price is equal to 10. Okay, so price elasticity, so remember there's elasticity of demand, and that will also be on the few pages I will share in the summary. Formula is P over P minus Q. Okay, and in this instance, they tell us at P10, and then at the bottom we have 10 minus 70. So when Q is 0, we've got a 70. So that change in at the bottom. So that is 10 divided by minus 60, and that will give us minus 0.167. Okay, so there is that option. Just look how close that one is. So if we set, let me just quickly check, 70 divided by 60 or minus 60, we would have gotten the option 1. So just be careful with this equation, and how to work it out. Sorry. But so this was when we looked at price elasticity of demand. They didn't ask you to work out the equation first. They went straight into what you need to do. Also interesting, and there might be in the next question something like that, where they normally also ask or add things like inelasticities and those kind of things. But that will be in the next question. Okay, so next question, and this time I have added again the formula how we will get to it, because our demand function is not a linear equation. It's a non-linear equation. It's actually an exponential function. So it's going to be a bit different. So you can look at this equation. They ask us where P is the price, Q is the quantity, find the price elasticity of demand at Q2, and say whether demand is elastic or inelastic at this point. Okay, so what I normally also love to do is to just draw that points where it's 1, minus 1. We know that if it's more than 1, it's elastic. If it is between minus 1 and 1, it's inelastic. And if it's smaller than minus 1, it's elastic. So I nearly looked at it and I'm like, okay, when something is going to be smaller than it's elastic, so it's not inelastic. So that one I can automatically cancel out. Okay, minus 1,4, it's going to be elastic, so nothing there. In between minus 1 and 1 is inelastic, that's fine. Between minus 1 and 1, inelastic. But at least by just drawing that normal one where one can eliminate between options, I already have eliminated one. Okay, now you can also see none of these are very similar. So depending on how we use the formula, we will get different answers. Okay, so let's look at what we need to do. So we need to get the differentiation, then we need to multiply by some change. So let's first write down that and let's see if we differentiate. So differentiation of that's 0,7 goes to the front, or minus 0,7. And then because, sure, what was it? Study unit 5, I think, with exponentials, when we differentiate that, it stays exactly the same. Okay, so that is our first one, and then we can say, but let's look at that q where q is equal to 2. Let's solve that. And here again, sure, one must be very careful when we get to it, that we use it correctly. So again, first we'll do what E will be. So it will be 0.7 times 2. So minus 1.4 E gives me 0, so this component gives me 0,2466. And then if I multiply by the rest, my final answer is minus 7,5952. Okay, so that now we still part of that first component. So let's just now look at what the next steps is. So first component, if I now look at that, so look at that, we need to replace it in there. So we've done the differentiation, but it's 1 over that now. And I sort of swapped those two around that you guys can also just see. So basically, we've now substituted that part in there. So we still need to look at my price divided by Q. So price so we're just writing that formula over, so it's nothing extra we need to do. Writing, that's my P formula, and my Q is 2. Okay, so at Q2, we know what the Q is, so we can substitute that. Okay, so now that nearly creates that we need to start with a lot more. haven't we done? Okay, there's a slight difference between this and this one, so unfortunately need to work it out again. So 0.7 negative times 2 negative 1.4. We need to say exponential of that. So again, let's just rewrite, because this is a big sum to do. So at the top, we will then have 44 times 0.2466, because that e minus 72 is 0.466, so that at least stayed the same. And we will divide by 2. So let's just put there multiplication, that we don't see it as a point. So 1 over 5952, 44 times that gives us 10,85. If I divide that by 2, we get 5,4251. So over 1. So if I divide that by 7.5952, I get that my answer is minus 0.714. Okay, which is option 2. Okay, this was a very long question. So again, from this one that was very easy to really a long question and a difficult formula. So please go and check again the recording afterwards. And they love to ask over E or a ln function in this non-linear functions, because it tests nearly, if you could do your differentiation, because you needed to differentiate the function. So it tests that. When it is exponential or ln, it tests that you have, nearly those functions, how that needs to manipulate it. They also then test in this one, if you know the formula, so that it's important that you need to say 1 over. So again, very important in this instance, because if it was not, it could have again been one of the other options that we work out. But question 14 really is a big question to work out. It will take you a lot of time. If it's possible to nearly keep something like this to the end, that can also be good. But yeah, it does take a lot of time. Okay. Question 15. So question 15, we're getting 3 linear equations, and they can ask you on a few different ways. So they could have asked you what is the values of x, y, and z, and say that x is 1, y is 2, z is 3, or something like that. But what they've done here is to say, okay, but instead of asking you what the values of those 3 is, they tell you, okay, well, you're going to work it out. So there's no nearly shortcut when we get to one of the x's and it's the only one in the answers. And they want that you say, well, the sum of x plus y plus z is going to be one of these options. Okay, so there's really no shortcut where it might have been easy to identify a Y or a Z. Now we need to nearly work out all three of them, because depending on what the numbers are, it can be any of these ones. Okay, so then for me, when I look at this, it's like, okay, we're sitting here with a Y, a X and a Y and a Z, X, Y, Z. Sure. So what I would probably have done is to say, okay, let's work with those first two. Let's see if there something comes out. So X plus 2Y plus 3Z is equal to 6, and then X plus 2Y is equal to 0. So if I now get that we say this minus that one, so we say 1 minus 2, x minus x is 0, 2y minus 3y is minus y, 3z minus nothing is plus 3z, 6 minus 0 is equal to 6. Okay, so now at least I've got something here. I can work with that one. That is my new formula 3. And I can work with the last one. So I can say formula 3 plus formula 4. So minus y plus y is 0. 3z plus minus z is 2z. So 2z is equal to 6. So z is equal to 3. Then I can put that back in there. So y minus 3 is equal to 0. So y is also 3. And then I can put the y and the z all back into that equation. So x plus 2y plus 3z is equal to 6. So x, sure, plus 6 plus 9 is equal to 6. So x is actually equal to minus 9. So x is minus 9 plus y is 3 plus z is 3, which is minus 9 plus 3 plus 3 is minus 3, which is option 1. Okay, so in this one, sure, there wasn't really an easy way to solve it. You nearly need to start and start eliminating so that one can see which ones will be the easiest nearly to use. Then nearly when we got one, then it was easy because of these formulas. We could even have put in this formula. I didn't need to go to, so in this formula already, we could have just said y was equal to 3. We didn't need to go that total route. We could have said in that one already y or x was minus 9. Okay, so we didn't need to go back to this whole one, we could have gone to the second one to actually get x. Okay, and you will see it was exactly the same. So it doesn't matter which one you use, but I would normally prefer the one that's the simplest to use, so that you can just eliminate maybe making a mistake with lots of numbers. Okay, so let's go to the next question. So we've done 15 questions already. So in this exam paper was the simplification. So that's why I also included it still. I know nearly what I did when we started the semester was to add a few of these things in as a warm-up. So just if it is in the exam as well, we have it covered, that we have tested it, and we still have enough time to go through another paper or two. So don't worry, we will see if there's anything else that creeps in. Okay, so what we'll first do is to see if we can simplify this first term, and then see if we can simplify the second term. So how I can simplify the first one is get rid of, so it's not square, it's not cubic. So what do we say? Fourth something. So when we bring that in, we can say, well, it is the -4 divided by 4. So x -4 divided by 4, y 3 divided by 4. So that is when we simplify that component. Let's now try to simplify this component. Remember, that is basically square root or to the power of 2 in certain instances. So let's see if we do that. So 4 square root is 2. X to the power of 2 square root of that is basically 2 over 2. Then at the bottom, we've got y, so it will be -4 divided by 2. Okay, so we will make it simpler now. So we've got x -4 over 4 is -1. We keep y 3 over 4. You can see in my answer set, it will be over 4. Then on this side, we've got 2x. 2 divided by 2 is 1, so we're going to keep that. Here we've got y -2. Sorry, divide by y -2. Nearly made a mistake there. So divide by y -2. Okay, so I've got x -1. I've got y 3 to the power of 4. I'm going to bring the 2 just in front so that we have a 2. So already not option 1. X to the power of 1. Then I'm going to bring the y -2 to the top. So it's actually y to the power of 2. -1 plus 1 cancels out. Okay, nowhere there's an x, so we don't need to worry. Then we can write this one way as 2 and the power 3 over 4. Okay, we don't have that anywhere. Another way to write this then is to say 2y, 4 times 2 is 8, 8 plus 3 is 11. over 4. So if we make it proper and improper fraction, so we see 2y11 over 4, which is option 4. So there wasn't really any shortcut in this. We just needed to simplify the equations out until we get to that final answer. We could have eliminated option 1, but then already there wasn't any excess in, so we couldn't eliminate anything else until we had our final answer. Okay, so then we go into the next one, which I also thought was a very interesting question. And again, here we e to the power. So we need to make things a bit easier. But let's look at the question and then what we actually need to work out. So the virus is thought to spread through a game reserve's impala population according to this formula, where n is the number of impala infected after T days. So now they're asking us, after approximately how many days are 200 impala infected? So we want to know actually after how many days. So what they want to know is, we know 200 impala is affected or infected, but we want to know after how many days. So we need to solve T. Okay, so when we need to solve T, let's start simplifying this, and then we will be at a point where we have e to the power of 0.12 t, where we will need to simplify that with a log function. But let's first. So the first thing I would do is divide on both sides with 125.5. So that gives me e to the power of 1.1 of 0.12 t. So then to get rid of the e, we basically say, but we're gonna take ln on both sides. Let's just check what is, or log, what is 200 divided by 125.5. So log of 1.5936 is equal to 0.152 t, and we can have done this, so that actually just disappears. So we've got log of 1.5936, which I have as 0.4660. That is equal to 0.12 t. So if I divide that by 0.12, I get t equal to 3.88, and then to the nearest day, so that rounded off gives me 4. So 4 there and not 4 there. Just again, a very easy mistake to make. You've got 4 and you nearly go to option 4 instead of going to option 3 with a number 4. Okay, so in this one, we were basically needed to work out and simplify a log function, where we were given a E, and we needed to get to the number of days. So we used the log function to get us that. Okay, so let's go into the last, I think, the last question for today, when we can call it a day. This again is looking at linear equation. So again, a bit different. Here they give us a table. They tell us in the sentence, or in the question, what is X and what is Y. And then we need to see if we get to these equations and which one is correct. Okay, so let's look at a small iron works manufacturer, two types of gates. So security gate and ornamental, sorry, and then they tell us the time requirements for each stage of production are given, and then they tell us there is a price component to it as well. Okay, so first we can say, they tell us that if a security indicates on denoted by security by X, other one by Y. So we can say then, well, for welding, we can make 4.5 security gates. We can make 2 ornamental gates, but all of them, we only have 9 hours available. So 9 hours max, so small or equal to 9 hours. So what I would do is with that one, let's see, 4.5 plus 2y. Okay, so that's fine. 4.5 plus 2y. Okay, so that one is still fine. 4.5 plus bigger. Okay, so that one we can eliminate. So option 3 is a goner. 4.5 plus 2y. Okay, still an option. Hey, so that was welding. So let's look at finishing. The same process. 1x plus 2y, and we cannot go above 400, so we only have 400 hours available, so smaller or equal to. So let's see, x plus 2y smaller, x plus 2y smaller, x plus 2y bigger, so that one eliminate. So we're sitting with two options left. Okay, then we could have included the selling price. They haven't done that. But then the other thing that we know is for X and Y, we can only make positive ornaments, or positive gates. So we can't make negative gates. So you can't make a -5 gates of security and 10 ornamentals. It all needs to be or 0 or bigger than 0. So that one can't be. So option 2 is the right one, where X and Y is also bigger or equal to 0. So again, for that one, think about it as when you look at your gate types, you can make 0 security gates, but you can't make negative. So it needs to be 0 or more. The same with ornamental. It needs to be 0 or more. You can't make more, or sorry, a negative number of gates. Okay, so that I think is it for today. We will continue next week with the rest. I'm just gonna, and to everybody listening as well, I'm just gonna add another question paper after this so that we can just continue. I am going to share this on WhatsApp as well, but also if you have any questions that you've picked up in any of your assignments, I think you guys will still write a mock exam unless you have done that also already. But again, also if there's any questions in there that you struggled with that you want me to go through, please pop it on the WhatsApp group. I will add that also in this presentation, so that we again just work through examples. I think that's nearly the easiest for this subject, is to see how many examples we can work through, so that we can nearly cover all the possibilities of questions that they can ask you. Okay, so that is it for today. We will have a session next week, and then after that, I'll check that we can also start having an extra session within the week as well, so that we can just prepare you guys very good for your exam. Okay, have a very good day, and a good weekend. Cheers, everyone.
Thank you. Bye-bye.
Bye bye.